Good morning, everyone. Thank you for the presentation. And I also wanted to thank the organizing committee for inviting me to come here and show this project and give us this opportunity. We have seen some strategies, key strategies, and I'm going to talk about the gasification in supercritical, the treatment of diastates in a gasification. This is going to recover energy from a waste or a wet material. How it works, or what the hydrothermal gasification is. Let's see. Okay, there we go. The gasification in supercritic conditions, hydrothermal. At the end, the gasification is a treatment, thermochemical treatment that needs wet material and dry material. This dry material must contain carbon. The matrix is just water under supercritic conditions, and this goes over 220 bars and 230 degrees Celsius. This water is different, with different conditions, because we want to change wet material and carbon in salts and water. Now we are using 250 bars, 250 degrees. You can see in this scheme, we are feeding the digestate as it comes. Then we put it inside the reactor when we have these conditions. In the supercritic conditions, in one way we have the water, and we have the carbon, and then we precipitate that, and then we obtain the sodium, potassium, and phosphate and nitrates. And on the other side, we are using syngas is rich in methane and hydrogen. And in another way, we are also recovering the water from this wet fraction. This technology, one of the most amazing advantages is that this advantage is avoiding the dry fraction, so all this energetic consumption can be saved. So this technology in the country that is pushing the most is France, because they have the commitment in 2050 to be carbon emission neutral. Within this strategy, they have a decarbonization of the gas grid, and within that, they have an axe. It's about biomethane and renewable gas. So there, they have the gasification in the middle of the scheme. This image is collected from the book published in France, the CEREMA. And they classify the organic material depending on the humidity. They have a material that is not easy to recover. They're not recoverable, but now they have a recoverable one that they are sending to incineration and landfill, and they are focusing the gasification in that part, because they have two parts. One is the circular economy, that is the salts and water for that use, and on the other side, have energy. It's a technology, a bridge between the energetic transition. This image that is also taken from the white book, you can see the value chain. If you see the amount of raw material that are treated are very versatile, mainly about the wet part. This drying phase is not necessary, so we go from sludge of treatment plant to gas. So of course you have to go through that process of gasification. It depends if you can play with more or less temperature catalyzers or not. But at the end you have three fluxes: the salts that are going to be used as fertilizers, the water that you can reuse, and the most important part, that syngas, that is energy. You can use it in situ or inject it in the grid. Also, you can use it as a raw material for the production of synthetic fuels. In this slide, what you can see is the business model of the gasification and their supercritical conditions. It has two streams, two ends. One is the environmental part that we are competing against the operational cost and regulation. If the operational cost is very low, makes no sense, because the regulation is too high, because this will be the no recoverable materials I showed you before. And then we have the energetic vector that I'm showing you here at the end. In this rate that I'm showing you, 1, 1, and 3.5, this energy is the energy produced slash the consumed energy. When we see the concentration of dry material in the biomass, in the waste, we can see that after that 15%, 20% where the diastates are, it makes sense. It makes sense only by itself, and economically talking is in this energetic way. And the optimal is around 40-60%, but if we go lower, for example, the slurry will make no sense, because we will be gasificating water, so it will make no sense. Of course, we have a mixed business model with the operational cost and the energetic value. Where we are now, we have two plants, a pilot plant and a factory where we develop our technologies. We have it in Albacete. And what we do this is we have a plant that can gasify liquids and solids. So there we try the new waste. When a client wants to do any trial, they send it and we try it there. Then we have a pilot, a demo, an industrial one for sludges and diastates of 100 kilos per hour, and is operating in Salamanca. This was designed thanks to the Eclosion project. It was financed by CDT. How we work is this way. When somebody's coming with a waste and they want to know how the gasification works, what we do is we do a theoretical study. Does this waste really make sense to treat? So we need the dry material and the wet part. It makes sense. Then we do a theoretical simulation. Then we see how this waste is behaving in this gasification. Does it make sense? Then we continue with the next phase. Trials in our pilot plant where we test all this new waste. Also, we see how we need to manage that, if it needs a pretreatment or how it works. So in this way, in this simulation and real trials, we know how we have to continue. Is this a new waste, or we need to learn more knowledge? Then we will go to 100 kilos per hour project. If it's a well-known project, then we'll go to 500 kilos per hour. So the industrial scales change, and these are the scales. The industrial demo is 100 kilos per hour. Then the next step is a plant of 500 kilos per hour. And the last part, that our technology is scalable, so we can add modules depending on the necessities. Another advantage, apart from the versatility of the wet part, is the space. We don't need much space to do so, because the pilot that we have in Salamanca is just a maritime container. I think is fewer than 4 meters, so it's easy to manage, are very compact. Who are behind this technology? We are CADE, we are an engineering and consulting company. Then over 10 years, we started developing our own technologies. We are 100 people, and we have 3 headquarters, and we have the factory and the main office where we develop our technologies, and in Madrid as well. Where we work in renewables, decarbonization, and 4.0 industry. Here you can see some of our technologies, like the Supercritical in the thermal storage. You will see that in the presentation. And of course, the last part is to insist that the gasification in supercritical water, the huge advantage is that it could treat wet waste and with organic material. That's what we need. And after that, we can obtain syngas, which is energy, salts, that you can use in fertilizers, and you recover the water. This technology is ideal to create these diastates and certain waste, and also it makes sense for this waste that has too much water. It's too wet. This is my contact info, and if you want to do any consultation or write, just contact me. Thank you so much.